It's clear, no? Okay. So Deborah, at least like rejoin or something. Okay. Assalamu alaikum, Pia. How are you?
Walaikum salam, sir.
By the way, Pia, do you have my playlist? Do you have my recorded lectures
Of which class, sir?
of like of the complete 12th batch, something like that? You must have, no? Did you get any recorded lectures from Learnivio or me? Hmm? Organic chemistry extra lecture and second.
Sir, if you have any playlist, please send me, sir.
I'm just sending it to you because
Yes, sir.
link address. Okay, so here you can find all the lectures of electrochemistry. I think electrochemistry is also done, no, in your school. Yes, Pia.
No, sir. Electrochemistry is not done.
What are the chapters? Then I forgot also. Okay, chemical kinetics is done now. Just a second. Okay, so you will get like there are 8 lectures on chemical kinetics. Okay. So let me give it to you here. Okay, so I have sent you the chemical kinetics playlist also. Okay. So you can do the lecture. I mean, you can do the chemical kinetics from there. Solutions हम लोग कर लेंगे यहाँ से, ठीक है? And other chapter that you are worried is biomolecules हम लोग इंशाल्लाह complete कर लेंगे, ठीक है?
Yes, sir.
Solutions तो हो गए, and then biomolecules.
Sir, coordination compounds.
Coordination compounds will take a bit of time. If you want the playlist, I will send you the playlist. Okay, don't worry about the playlist. But I cannot take only for one person. No? I have to see other students also. Okay, so coordination compounds will not be able to do. But if you want the recordings, I will send you the recordings. Okay, Fadil is here. Also, one more thing is that Aliza, Fadil, were you present in the morning lecture?
Morning lecture, no sir.
Why? Did you not get the link?
Sir, I wasn't aware there's a morning lecture.
Okay, so there will be tomorrow. You have to attend. Okay.
Okay, sir. For which chapter?
Been, are you added in a group? Are you added in a group?
No, sir. No, sir. Not yet.
Not yet. Wait a second. Maybe you don't have that active, na, Joe. I mean, no one can add you in a group. You must have got an invitation, but
I'll actually, the messages come to my dad. I'll just cross check with him after the class.
okay, fine.
Yeah.
Maybe you can share your personal number with Learnivio. That will be better because
Yeah. I told my dad the same thing. Yeah.
Because we are going to be in contact almost, like, at least not with me, but for the other classes, you will be in contact with Learnivio almost daily. So it's better that you give your own number. Okay.
Okay, sir. Okay.
Okay. So in the last lecture, we saw acidic dehydration, and we have seen how to write the products. That means more substituted alkene is the major product. We'll start with some questions. and then we will move on to the next topic. Okay, so please write the question. Oh. Guys, my system just hanged, so I will just rejoin. Okay, please be in the class. I will just rejoin.
Yes, sir.
Sorry for that interruption. Give me a second. Let me get the post pollutions. Please write. Write the major product for following. Write the major products for following. Okay, please see here. Okay, so the basics I'm once again repeating. Okay, guys, you have to identify the alpha and beta carbons. Then you have to identify the beta with the least number of hydrogens. Then you have to remove hydrogen from that beta which is having the least number of hydrogen atoms, and then make the double bond. Okay, so can you tell me, for example, I take this particular example of the first one. This is my alpha carbon. This is my alpha carbon, and this is beta carbon, and this is also beta carbon, right? But this beta, it has 3 hydrogens, and this beta, it has only 2 hydrogens. That is why from alpha, you will remove the OH. From beta, you will remove one of the hydrogens, and there will be a double bond between alpha and beta. So this is going to be the product, okay, or rather the major product. Okay, please write this down. And then also, once again, you identify these things, okay? Your answer should be as labeled as my answer, okay, guys? Please make sure that you are labeling each and everything, alpha, beta. You have to work on the problems. Don't try to write the answer directly. Okay, please don't try to write the answer directly. Okay. So at least for now, even in the board examination, also identifying alpha, beta, and then number of hydrogens in both of them, and then write the answers. Okay. So please start, and please giving you guys 5 minutes will be more than enough. I hope so. And please send your answer once you are done. If you are not able to do, please let me know under 1 minute. But sir, I'm not able to do any one of them. You try second, third, fourth. Okay. And if you can't do a question in 1 minute, please let me know. If you get stuck, then also please let me know. Aliza, are you done with the second one? Aliza, are you done with the second one?
Yes, sir.
Okay, Deborah, are you done with the second one? Deborah, are you done with the second one? Fadil, what about you? Answer me, please, Deborah.
Yes, sir.
You're done. Fia, second one हो गया?
Yes,
Yeah.
done.
Done? ठीक है. चलो. Deborah, you have not answered. Please answer, Deborah. इस तरह चुपचाप बैठने से कुछ नहीं होगा. Doing second one नहीं, तब तो नहीं हो रहा है आपसे. Did you identify alpha and beta, Deborah? Yes or no? Did you identify the alpha and beta? Did. Okay, fine. देखिए गाइस, आपके पास ना टाइम थोड़ा कम है, ठीक है? तो आपका सिलेबस थोड़ी सी ज्यादा तेज रफ्तार में रहेगा, ठीक है? क्योंकि टाइम तो उतना ही है.
Sir, I have sent you the photo, sir.
So you have sent me the photo. गर्दन को टेढ़ा करना पड़ेगा. सेकंड पहला तो सही है. सेकंड वन, हाँ, सेकंड वन में दोनों जगह सेम है. बीटा अल्फा बीटा बीटा. वेरी गुड, वेरी गुड. Easy है फिया, no problem, right?
No problem, sir. It was all fine.
Okay. आपको अपने अंदर इम्प्रूवमेंट लग रहा है ऑर्गेनिक केमिस्ट्री में? चीजें समझ में आ रही हैं? यस किया?
Sir, can you repeat?
I mean, are you seeing improvement in your organic chemistry?
Yes, sir.
Like,
Yes, sir.
in like when you're doing NCERT also, right?
Yes, sir.
Did you watch that organic conversion lecture I have sent you now?
Today we did the same thing, right, sir?
Today? Where?
Sir, which lecture you're talking about?
Organic conversions for haloalkane halorine. I have
No,
sent
sir.
it in the. So you have not watched. If you look at in the group ना,
Yes, sir.
वहाँ पे हमने मैसेज भेजा था एक बार. Just a second.
Okay, sir.
If you scroll a bit up,
Yes, sir.
ये भी जब हमने बॉयज वाले ग्रुप में भेजा था क्या? Just a second ना. वो अच्छा सिर्फ बॉयज वाले ग्रुप में भेजा था. Oops, oops. Extra process of अच्छा फादिल वगैरह. फादिल, please send the answers. Okay.
Yes, sir. Sir.
Guys, I'm really sorry. I'm not guys, actually girls. I'm really sorry. Boys के ग्रुप में तो हमने भेज दिया, आपके ग्रुप में हमने नहीं भेजा था. Father, I got your answer. Second one correct. Third one में C. What is the mistake? आपने CH3 को टाटा पर भेज दिया.
CH3 हाँ.
ठीक है,
Okay.
चलिए. Everything else is fine. देखिए आसानी हुई ना अल्फा बीटा करके. बताइए फादर.
हाँ. जी.
ठीक है. Aliza, where is your answer? Aliza and Deborah, please send your answers. Deborah has sent me. Deborah, this one is fine. This one is also fine. Deborah, fourth one is not right ना. You have not identified the beta and hydrogens. देखिए जहां तक आपने किया है 2 हाइड्रोजन अल्फा, वहां तक ठीक है. फिर आपने यहाँ पे if you don't identify the number of beta carbons, then it will be bit tough. Okay, so for this all of you have got it right. Oh, Aliza, आपका आंसर. Aliza, your answer is not here. What happened, Aliza?
This is ending.
Sorry, you sent a link on conversions of organic solvents.
Yeah,
You send that to me, sir, because I can just find the playlist, sir.
अच्छा ठीक है, हम भेज देंगे आपको. अभी हम क्लास खत्म करके भेजते हैं. ठीक है.
Yes, sir. After class, sir. Yes, sir.
अच्छा, so which number is this? यार हमने सेव नहीं किया हुआ. This is Aliza, I think ना. थर्ड में किसको कंफ्यूजन है? Aliza, right?
Yes, sir.
हाँ ठीक है. देखिए सेकेंड वाला तो I think it's fine. Both of them are having 2 hydrogens, so you can make the double bond anywhere, right? Make a double bond here. Now see in the third one, this is your alpha, and we have beta here. This is beta, and this is also beta, right? Now this beta, it is having how many hydrogens? It is having 2 bonds. That means it is having only 2 hydrogens, right? Here, this is having 1, 2, 3 bonds. 4 minus 3, that will be equal to 1 hydrogen. So here we are having 1 hydrogen. So you will make the molecule like this. OH will be removed and CH3 will be as it is. Double bond between alpha and beta. Double bond between alpha and beta. Similarly, in the fourth one, please see. Deborah, please see here. You have alpha, and this is your beta, and this is also beta. No? Now this beta is having 3 hydrogens, and this beta will be having only 1 hydrogen. So you'll remove First of all, make everything as it is except the OH. OH is not there. And then from alpha and beta. Double bond between alpha and beta. Got this? Yes or no? Please tell me. Alisa, you got the third one?
Yes, sir.
Sir,
Okay. Yeah, tell me. Saying something.
no, sir, I was saying I rejoined.
Now, please see, there is a case which is quite important. You have OH. Okay. And let us suppose you have two CH3s here. In this carbon atom, you have two CH3, one CH3 here and the other CH3 here. Now, here also you will identify this is your alpha, this is beta. This beta is having two hydrogens, and this beta will be having, see, it is already having 4 bonds. That means this beta will be having 0 hydrogens. Let me name this as beta 1 and beta 2. Which beta is having less hydrogens, guys?
Beta 2, sir.
Beta 1 or beta 2? What about others? Alisa, Deborah, Pia. Anji. Which beta is having less hydrogen? Beta 1 or beta 2? Alisa, Pia.
Beta 2.
Beta 2, sir.
So you will basically what students generally do is that they remove the O. Okay. So they make alpha and beta 2 bond like this. Okay. They make a bond like this, but it is completely wrong. Because if there are 0 hydrogens, then how can you remove a hydrogen from that beta? What happens at beta? You have to, I mean, at least remember that, all of you guys, that we remove hydrogen from the beta. If there is no hydrogen, then how will we remove the hydrogen from the beta carbon? You got it? Yes or no? Please tell me. Guys, we have
So,
Deborah,
so
Alisa.
there will be no double bond.
There will be double bond, but it will be from beta 1. Because essentially speaking, we have only one beta carbon which is having a hydrogen atom, right? This beta 2 is not going to be reacted because it is not having any hydrogen. So how can you remove the hydrogen from there, right? So you will be, there will be a double bond, but with beta 1. Got it? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
All of you got this? Okay, thank you. Okay, now there are a few questions in NCERT in which you have to predict the reactant. I mean, here we were predicting the product, no? What product will be made, but there are some questions in which you have to predict the reactant. Okay, so for example, see, there are some questions here. See, for example, how will you synthesize? Not this one. This one. Wait a second. You don't have that type of question. That was in the method of preparation. Wait a second. I got confused. I mean, we have a reverse reactions also, no? From alkene to alcohol. Okay, so I leave it. Okay, so these are the only type of question that you are going to get in the case of acidic dehydration. Right, next, this is the 5th reaction, I think. You see, alcohol was 4th. Yeah, so this is the 5th reaction. Please write oxidation of alcohols. Oxidation of alcohols. Okay, please write the oxidation of alcohol. The oxidation of alcohol involves cleavage of CH and OH bond, CH and OH bond, and formation of C double bond. Okay, so basically what happens, you have carbon atom, and this carbon atom, which is the alpha carbon, it should have a hydrogen. It should have a hydrogen. Okay. Now what will happen? You are going to remove. You're going to remove the hydrogen from the carbon, and you are going to remove the hydrogen from oxygen also. If you add any oxidizing agent. So what oxidizing agents you will see those reagents specifically, but right now general oxidizing agent, you will get carbon. These two bonds will be as it is and double bond. So we have removed this bond and this bond. Okay. The important thing is to note that what is happening here, CH and OH, both of these are breaking, and C double bond O is getting formed. So the most basic idea that you can have about a reaction is regarding what bonds are getting broken, then what bonds are getting formed. Okay. So always try to keep that in mind, if nothing else. Okay. As you can see here, we are removing hydrogen and hydrogen. So basically we are removing H2. That is why this reaction is AKA, please write. This reaction is AKA. AKA is also known as dehydrogenation. Because we are removing H2. Now, next point, the formation of product. The formation of product depends on the type of alcohol, whether it is 1 degree or 2 degree or 3 degree, and the oxidizing agent, whether it is strong or it is weak, whether it is strong or weak. Okay, so we know 1 degree, 2 degree, and 3 degree alcohol. So we can
Sir, it
look
is
at it.
dehydrohalogenation or hydrogenation only?
What we are removing here, we are removing. What are we removing?
Hydrogen, sir.
And only hydrogen. So it will be hydrogenation, dehydrogenation, right? There is no existence of halogen only. You don't have any halogen here, no? Okay. Right here. Next, please write oxidizing agent. Okay, so there are two types of oxidizing agents. You have the strong and the weak. Here, strong oxidizing agent, and right here, weak oxidizing agent. In strong oxidizing agent, number one is right. You can have aqueous, or you can use alcoholic, or you can use acidic KMnO4. Second, please write acidic K2Cr2O7, or instead of K, potassium, you can use sodium also, Na2Cr2O7. Third is HNO3, and fourth is chromic acid. This is H2CrO4. H2CrO4. So these are strong oxidizing agent. Then we have the weak oxidizing agent. Number one, please write Collins reagent. Collins reagent. The structure for this is CrO3 dot 2C5H5N. Okay, but you just need to remember Collins reagent. And Secondly, we have PCC. You only need to remember PCC is a weak oxidizing agent. The name is quite long. You can just type it out and let up with the spelling sometimes. So it is pyridinium. Pyridinium chlorochromate. Okay, this is the name, pyridinium chlorochromate. I mean, you can have some spaces if you want to read it properly. Okay, now its structure, you don't have to remember these things, okay, but it should be present in your notes. CrO3.C5H5 N.HCl. Third one is PDC. Third one is PDC. Now its name is very similar to this one. So it is pyridinium dichromate. Pyridinium dichromate. And its structure is C5H5 NH2 with 2 positive charge dot Cr2O7 2 negative charge. Is everyone done? Yes or no? Please tell me.
Yes, sir. Can you show the last point of the previous slide, sir? Yeah.
All of you done?
Yes, sir.
Now, there is also one more reagent that is in the weak oxidizing agent. You can write the fourth one also, which is very much used. It is CrO3. Okay, and sometimes it is generally referred as CrO3, which is chromic anhydride. What do we write? Write it as chromic anhydride. Okay, so it should not be used in the presence of water, because if you use it in the presence of water, it will become chromic acid, and chromic acid is going to be a strong oxidizing agent. Okay, so it should be present in what we can see in anhydrous medium, where you don't have any water molecule. Is that clear? Yes or no? Please tell me.
Yes, sir.
See next. This is about the oxidizing agents. Okay, so strong and weak oxidizing agent. Now let us see what will happen if I have a 1 degree alcohol. Okay, so please see, you have 1 degree alcohol, which is RCH2OH. R CH2 OH. Then in this case, if you are using weak oxidizing agent, what we are using? We are using weak oxidizing agent. Weak please W. Sometimes when I ask after 2 or 3 classes, no, that okay, how to convert alcohol to aldehyde, then students then say, sir, we will use WOA. Okay, so WOA is not a reagent. Okay, it is a class of reagent in which we have different reagents. Okay, so WOA is weak oxidizing agent. You have to use any one of them: Collins, PCC, PDC, CrO3. Okay, and it is going to convert to aldehyde, which is RCHO. We'll have R and then carbon with a double bond and then H. Okay, now if you after aldehyde, you can further convert it to carboxylic acid if you are going to use strong oxidizing agent. Okay, if you use strong oxidizing agent, then this aldehyde will be converted to R. The C double bond O will be as it is, and there will be one more OH, one more oxygen here. So here we have 1 degree alcohol. Weak oxidizing agent, it converts it to aldehyde. And strong oxidizing agent will further convert it to carboxylic acid. And if we are going to use strong oxidizing agent on alcohol itself, then also it will get converted to carboxylic acid. Okay, is this clear, guys? Yes or no, please tell me. थोड़ा इसको हम अच्छे से रन देते हैं. आप लोग जितना कर सकते हो कर लीजिएगा. And this will also get the blue color because some of everything is blue here. And maybe this whole thing will get a red color because when we are having weak oxidizing agent, it is getting converted to aldehyde. Strong oxidizing agent is getting converted to carboxylic acid. Is this clear, guys? Yes or no, please tell me.
Yes, sir.
Now, what about, this is all about aldehydes, right? What about ketones? What about ketones? So ketone is a very simple
Sir,
case.
if we further applied weak oxidizing agent, will get ketone.
No, you won't get ketone. How will you get ketone? For ketones, you need 2 degree alcohols. Okay. So if you have R, CH, and OH is here, and then you have some other alkyl group. Okay. So in that case, if you are using weak oxidizing agent, okay, then you will get R. The CH will be gone. From carbon, you will get remove hydrogen. From oxygen, also remove hydrogen, and you will get R dash. Okay, that's it. So from 2 degree alcohol, you will get ketones. Okay. Now, please write here. a few notes. The first point is, please write, oxidation of third-degree alcohols is very difficult due to the absence of alpha hydrogen. Whenever we write due to, because, please start assuming an assertion reason question can come from here, okay? Or Y type of question can be coming from here. So please see what is 3-degree alcohol. It will be R bonded to carbon with some other R, with some other R, and then OH. Okay, so please write. And obviously here we don't have any hydrogen, right? That is why from carbon, what are we going to do? So carbon-carbon bond are quite strong. That is why we need a very drastic condition. That means high temperature and quite highly acidic solutions. Okay, so please write, they are oxidized. They are oxidized using acidified KMnO4 or K2Cr27 at high temperature. Okay. Now, when we oxidize them, then what is going to happen? Then this bond can also break, right? This bond can also break. So multiple CC bond breaks. Multiple CC bonds break, and a mixture of ketones and carboxylic acid is formed. So we don't get any particular product. Okay. So that is why the 3-degree oxidation of 3-degree alcohol is not there in your syllabus. And it is not also useful because it is going to give you mixture. जहाँ पे एक product मिले ना, that is a good reaction, because if you want to make a particular thing, you want to make only one thing, right? That is why generally it is good if we get one product. And if we are getting more than one product, then those products should be easily separable. If they are not easily separable, then it is also going to be again a difficulty and again a lot of expense, because we have to separate them. And easy separation means you can either filter it out. If it is a solid and liquid, then it is perfectly fine. If you are getting two products, one is solid and the other one is liquid, you can just filter it out. And if they are two liquids, then what we can do? We can do fractional distillation. That means we can do distillation. The one with lower boiling point will boil off, and then we can cool it down to get the pure product. Okay. So this is regarding the oxidation, and a very similar reaction happens with the hot copper. Very similar reaction. Please write sixth one. Reaction with hot copper. Reaction with hot copper. Now, again, it's going to depend on. My voice is not clear for everyone. Alisa, am I audible properly?
Yes, sir.
क्या हो गया आप लोगों को? Fia and Deborah, you guys are having some difficulty. Please see. Number one, we have primary alcohol. Primary alcohol. If I react primary alcohol with hot copper, so primary alcohol is something like this. If you react this with copper at 573 Kelvin, then what we are going to get? We are going to get, see how many carbons? Please remember the carbon atoms. Okay, 1, 2, 3. So 1, 2, 3 carbon atoms, and here you will get CHO. Acha. and plus you will get H2 here. Actually, one more thing that I want to show you guys here is that whatever, for example, R is 1. So here also R is 1. And here we have one more carbon. So 2 carbon atoms. Okay. So whatever be the number of carbon atoms in alcohol, the same number of carbon atoms will be there in aldehyde and carboxylic acid. Okay. Generally, people do a mistake that, for example, if I have something like this, then in the product, they will write it like this, CHO, which is utterly wrong now, because here we have only 1, 2, and 3 carbon atoms. How can you get 1, 2, 3, and 4 carbon atoms, right? So please take care, especially in the case of aldehyde, especially in the case of aldehyde. Okay. Now this is 1 degree alcohol. It gets converted to aldehyde. Right. The second, when you have secondary alcohol, the secondary alcohol is something like this. We'll make one more carbon like this here. Now, generally people don't do mistake here. Here you can write heat just like this, and the OH is replaced by double bond O. That's it. Okay, so this is generally easy rather than the case of aldehydes. Aldehyde में बच्चे थोड़ा सा mistake करते हैं. Third one, please write.
Sir, can you show the first one? Sir, can you show the topic also?
Tertiary alcohol. Please write it down आराम से. ठीक है? Then I will. Again, here also you will get hydrogen gas. Okay, so you can write furthermore, 2 degree alcohol is going to give you ketone with the same number of carbon atoms. All of you done? Yes or no? Please tell me.
Yes, sir.
See, now for tertiary alcohol will be something like this. You have 1, 2 carbon atom, 3 carbon atoms, and this carbon is tertiary, so it will be having OH group like this. Okay. If you react this with copper and heat it, so it gives you alkene. Okay. It gives you alkene. That means the OH will be removed and there will be a double bond plus water will be removed here. Okay. So in tertiary alcohol, the same problem exists, that this carbon atom, it does not have any, it does not have any hydrogen. So what does it do? It removes the OH from here and one of the hydrogen from here. And then we get what? We get alkene. Okay. So if you have 3 degree alcohol and you get alkene.
Sir,
After
from
this, right,
secondary alcohol, what do we get, sir?
ketone.
Okay, sir.
All right. All of you done till tertiary alcohol? Guys?
Yes, sir.
Okay. Like the look of it. can write these 5 questions. Guys, see what to do. First of all, identify whether it is 1 degree or 2 degree. Okay. Then in 1 degree, you will identify whether it is strong or weak. If it is strong, then it will give you carboxylic acid. If it is weak, it is going to give you aldehyde. In 2 degree, you don't even have to identify anything. Okay. Whatever be the oxidizing agent, you will just make a ketone. Strong or weak देखने की आपको जरूरत नहीं किसमें. Generally, if 2 degree alcohols don't see strong and weak because I am saying that because strong oxidizing agent plus 2 degree alcohol उन्होंने केस ही नहीं दिया है तुम्हें. ठीक है, in NCERT कोई reaction नहीं. ठीक है, that is why you don't have to worry if they have given 2 degree alcohol and no matter if they have even given K2Cr2O7 or KMnO4, then also make ketone. Okay, don't make anything else. 2 degree में हमेशा आपको क्या बनाना है? ketone. Alcohol में आप 1 degree 2 degree identify कीजिए. All of you got it ना? How to do this? Yes or no? Please tell me. बोले.
Yes, sir.
ठीक है, तो पहला वाला बताइए क्या हो जाएगा? This one is 1 degree or 2 degree? This alcohol is 1 degree or 2 degree?
2 degrees,
First
sir.
one, 2 degree. So the product is going to be aldehyde or ketone?
Ketone.
बस
Ketone.
सीधा ketone. अगला बताएं. This is what 1 degree or 2 degree? Second one,
1 degree.
1 degree, right? And how many carbons? 1, 2, 3, 4 carbons. Okay, remember that. H2CrO4, it is strong or weak? H2CrO4. Strong or weak? Oxidizing agent. Tell me. H2CrO4 is strong or weak oxidizing agent? Oh my God. You have it in your notes now. H2CrO4 is strong or weak? You guys forgot? Oh my God. हाँ बताएं. H2CrO4 is strong or weak? Oh my God. Really, Aliza? अरे बोलो ना. Aliza, Deborah, Fadil, Fia.
Sir, it's strong, sir.
Strong, na? Yeah.
Yes,
So 4 carbon atoms, 1, 2, 3, 4, and what it will give? If it is strong, it will give what? Aldehyde or carboxylic acid? Aldehyde or carboxylic acid if it is strong?
Carboxylic acid, sir.
Very good. So it will be COOH. Okay. Now what about PD here? Again, do we have 1 degree or 2 degree here?
1
The third
degree.
one, 1 degree. How many carbons?
2.
2 carbons. Okay, so you will write it like this CH3 and the second carbon will be CHO. ना ऐसे अच्छा नहीं लगेगा ना CHO लिखना 2 carbons के लिए. ठीक है. Either you write it like this, maybe you can write it ऐसे करके double bond O और यहाँ आप hydrogen लिख दो. Then it is fine. Write it like this. Now here we have 2 carbon atoms. Here this is 2 degree and this is 1 degree. So first of all, I will count number of carbon atoms 1, 2, 3, 4 carbons. So 1, 2, 3, and 4 carbon atoms. Second one will be converted to ketone because it is obviously 2 degree को ketone ही कर देना. CrO3 1 degree में क्या हो जाएगा? CHO हो जाएगा. Got this? Yes or no? Please tell me, guys. All of you
Yes,
got
sir.
this? Now PCC it does not affect the double bond. लेकिन generally जो oxidizing agent होते हैं ना, वो क्या करते हैं? Double bond को convert कर देते हैं. For example, if you have something like this, इसको वो convert कर देते हैं किसमें? Alcohol में convert कर देते हैं. ठीक है? But in this case, PCC, since it is a weak oxidizing agent, it does not affect the double bond. That is why you will write everything. So you have 1, 2, 3, 4 carbon atoms. The 4 carbon atoms will be as it is. The double bond will be as it is, and it will be converted to CH. Okay. All of you got this? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
No problem, right?
No, sir.
ठीक है. इसके बाद 2 छोटे-छोटे reactions हैं for phenols. ठीक है. So we will write that and then get done with today's class. Write the heading. Chemical properties of phenols. The first reaction is very important, reaction with zinc dust. Reaction with zinc dust. So we have phenol. And we treat this with zinc. And you will get benzene. So very easy and important conversion. Okay, so you can directly get from phenol to benzene. फिर benzene से तो रास्ते खुल जाते हैं ना. From benzene you can get haloalkene. From benzene you can get acetophenone, benzaldehyde, many things you can get from benzene. Okay, so very important reaction if you want something which is starting from phenol to benzene. Okay, so the second is oxidation of phenol. I made quite a good phenol, so I will just copy this. Phenol, when it reacts with Na2Cr2O7, in the presence of H2SO4, it gets converted to a very intimidating looking molecule that is known as benzophenol. You have double bond here, and double bond O is here, and double bond O is benzophenol. Okay. Three more classes, inshallah. What's one?